I really like this example because it requires a really good understanding of triangles. It says, a triangle has sides 8, 15 and 17. Prove it is right-angled. But we've got to prove it's right-angled using the cosine rule. So if it's right-angled, we know that it'll have an angle of 90 degrees in it. So we could set about finding an angle in this triangle that is 90 degrees. Now, if we know this particular feature about a triangle, which is the biggest angle is always opposite the longest side, then we know which angle to target. So a triangle has sides 8, 15 and 17. 8, 15 and 17. This is the angle, and I'll call it theta for now. We want to show that theta would be 90 degrees. Now, like I said, I suppose you could work around and find all three, or if you just chanced upon finding this one first and it was 90, then you're done. However, if you started with, say, this angle over here and you found it and it wasn't 90, then you'd have to keep moving around your triangle until you did find the one that was 90, which is very time consuming. So maybe this question's set up to test that you do know that the longest side is always opposite the biggest angle. And in a right angle triangle, the biggest angle, there's nothing bigger than 90 degrees. You can't have that. So, knowing this, I'll be calling that C, and that side C, and this is A, and this is B, and I'll be finding angle C. And I know that angle C is the cos inverse of A squared plus B squared minus C squared over 2AB. So you can see there that I've substituted the values in. It's very important that your longest side goes opposite the angle that you're finding here, and in that case it's the longest side. It was called C, and that was 17. And in the calculation, cos inverse of that fraction is, yes, of course, 90 degrees. So we've shown that a triangle with sides 8, 15 and 17 would be right-angled, and we've shown that using the cosine rule. Now, this example involves your understanding for the angle of depression. Angle of depression is when we're up high and we're looking down. So the angle is not actually in the triangle in this example. 75 is not in the triangle. But we know that this is a right angle, and we could work out that the size of the angle inside there would be 15 degrees. Now that's going to be really important, that in our triangle we've got 15 degrees. You can see that we've got two triangles here. We've got a big triangle and we've got a small triangle. The length of J to K is 20, so that's not a right angle triangle. J to K to M is not right angled. M to K is 18. Calculate the angle of elevation. Angle of elevation. So the angle of elevation from M to K in here, we've got to find this angle. Angle of elevation from M to K. Now, what we do know is that the angle of depression there is equal to this entire angle. That would be, that red angle all the way around would be 75 degrees. We don't want all of that, we just want this little bit down the bottom. So what we're going to do is we're going to find the angle inside here. We're going to call it, let's say we'll call it theta, and we're going to find theta in this triangle. It's a non-right angled triangle. And if you think about that green triangle that I've just drawn, J to M to K, we know that this side is 20, this side is 18, we've got theta here that we need, and we've got a 15 degrees up there. Well, actually, I don't think I'm going to use the cosine rule because I don't have all three sides and now I'm talking two angles. So hopefully you can see that actually in this example you need to go back to the sine rule. To find this angle theta, we need to go back to the sine rule. So you can see that I've written my sine rule, A on sine A, calling the unknown angle A, going back to the sine rule. And again, this is a good test of how well did you learn the sine rule back in those exercises. This is feedback for you. Do you need more work on it? Because this is the type of situation you're going to be in. You're going to be thrown a question. You have to know which rule to go to. You have to be able to use the rules. So, A on sine A, B on sine B. A, we said, would be 20 because it's opposite the theta. 15 was the angle we know, and the side opposite is 18. We cross multiply. We get 18 times sine theta, 20 times sine 15. Divide both sides by 18. Then we need to take the inverse sine. And when we do that, you can see there on your calculator, you get 16.7. To the nearest degree, we're going to call that 17 degrees. Now, back to the actual question, which was the angle of elevation. Therefore, what did we say? We said that the angle of elevation from M to K, just this little bit down here, is the whole all of 75. Take away the theta that we've just found, which is 17, which is 58 degrees. So that's a little bit difficult and not beyond what you could be expected to do. And it did say back here that it was an example of a two triangle problem. So just be aware of that.